Question 1. Do I have my pen ready? Yeah. A spinner number 1 through 4 spun 5 times. So let me just make sure. There's a spinner. 1, 2, 3, 4. They spun 5 times. Each time the spinner landed on a composite number. Well, the only composite number is 4, so 4, 4, 4. So it landed on 4 or 5 times. What's the probability that what's the probability that will be a prime number on the next row? Well, on the next row, the prime numbers are what? 2 and 3. So what's the probability of landing on 2 and 3? Well, landing on 4 or 5 times in a row has no relevance here. So the probability of landing on 2 or 3, it's going to be, well, 2. I should write 2 or 3. The probability of landing on 2 or 3, well, I have 2 chances out of 4 or half. So this is just, I guess, just a distraction. Okay. A bag has, 4 yellow. I'll write this down. 4 yellow, 2 blue, 5 red. What's the probability of selecting? So you want to select a yellow and followed, and yellow, and then another yellow without replacement, meaning if you take the marble out of the bag, you're not going to put it back. So the probability of getting a yellow, and let's find the total first. So it's 4, 6, 11 total. So on the first one, the probability of getting a yellow is 4 out of 11. You take the marble, put it outside, and go back to the bag, and you'll notice that instead of 4 yellow, now you have 3 yellows. So the probability now, and you notice that the total has changed, so there's 10 in the bag now, and only 3 yellows. So the probability, can I simplify anything? Is yes, I can. This becomes 2, this becomes 5, 6 over 55. Okay. That's, make sure you are very careful with the word replacement and no replacement. Okay. And this one is with replacement, so it means that once you take it out, you put it back into the bag. So we got 6 pink, 3 black, 4 white. What's the probability of getting a pink and then a black marble? But this one is with replacement. So the probability of getting a pink, let's find a total, I always forget, is 13 total. Probability of getting a pink is 6 out of 13. You look at it, you put it back in the bag, and now you get a black marble, and the black marble will be 3 out of 13 again. Can I simplify anything? No. 6 times 3 is, 18, and 13 times 13 looks like 169, right? Yeah, 18 over 169. Not that great of a chance here. Number 4, should be a quick review sheet here. The table below shows the results of picking a marble from a bag with replacement. Okay, so you take one, put it back, take another one, put it back. Based on the experiment, what's the probability of picking a green marble on the next turn? So we're basing it on here. So let's find a total first. 12, 10 is 20, 22 plus 28, that's 50. So on the next one, the probability of getting a green using these results would be a 15 out of 50. 15 out of 50, you can divide by 5, you get 3 over 25. So on the next try, if you were to try to get a green, you would, based on this, on these past results, you would have a 3 out of 25 probability of getting a green one. So this one, you're actually basing it on the results of your experiment. 5. So what is the probability of picking a number greater than 5 on a die? Well, a die has 6 numbers, right? Greater than 5 is just 1, so it's just a number 6. The probability of picking a 6 is 1 out of 6, and it would be unlikely. Why is this question here? 6, right? Kind of weird. Drinks for an afternoon at the school carnival were recorded in the table. What is the experimental probability that the next drink is a small cocoa? Okay, so based on the experiment again. So we got to add all these, right? So there were 77 orders for small soda, 68 for a large, 98 orders of small water, 45 large water, 60 small cocoa, and 52 large cocoa. So let's add all these orders. So they're all orders. I'm going to use a calculator. 77 plus 68 plus 98 plus 45 plus 60 plus 52. There were 400 orders, right? And we want the probability of small cocoa. So based on this, there was an experiment, not experiment, there was a fair, right? And somebody wrote down there were 400 orders, and 77 out of the 400 was small soda, 68 out of the 400 were large soda, etc., etc. So we're interested in small cocoa. Probability that the next order, whoever's in line next to buy a drink, that the probability that the person is going to choose small cocoa is going to be obviously 60 out of 40, and we can simplify, divide that by, I don't know, 20, and you get 3 out of 20. Okay. 7. The table below shows the result of an experiment. Again, an experiment based on the data. How many times would you expect the die to land on 5 or 6 in the next turn it spins? So here are the numbers. So let's add up how many trials there were. So that's 12 plus 6 is 18 plus 4 is 22 plus 8 is plus 30 and plus 6 is 36. So there were 66 cube tosses, and we want to base it on the experiment. So the experiment has 36 tosses, right, on the experiment, and we want a 5 or a 6. So on the next toss, what's the probability of landing on a 5 or 6? Well, according to the experiment, we had 5 or 6 was 8 and 6. So 14 out of 36 times you landed on 5 or 6. So that is our experimental probability that the next roll will land on a 5 or 6. Use the table below to answer the question. What is the question? Which class is better represented by the mean and the median? Okay. So I'm going to say, and again, I don't think you have to do any calculations. The mean is definitely class B. The median, I think the median would be class A, because the mean, obviously, because there are no outliers in class B, right? This is class B, no outliers. So the mean is better used, or better. It represents the data better represents the data when there are no outliers. And then median will represent class A. Well, because you can tell that the numbers are really spread out, right? So probably better off using the median to represent class A. Otherwise, either it's going to be too high of a number or too low of a number, right? It's going to make your data look too high or too low. Which one has the greater MAD? So we actually have to. So the greater MAD, obviously, is this one. And again, I'm not calculating it, because remember, the closer your data is, right, clustered, the less your MAD is going to be, right? So if you find the median of this, I don't know, let's just assume it's somewhere over here, right? We draw a line, represent the median, the mean, right? So, and going back to this, let me just take that back. So if you added 3, and then I'm just going to say 3, 4, there's 3 4s, there's 5, 4 5s, 2 6s, 1 2 3 4 5, 1 2 3 4 5, 2 8s, and 1 9. So let's just find find the mean here. So that'd be 3, and I'm going to 12 plus 20 plus 12 plus 35 plus 16 plus 9. I think it's easier to enter those. So I'm finding the mean. I'm adding all the values up. So it's 3 plus 32 plus 12 plus 35 plus 16 plus 9, and that equals 107. So if I were to add all these numbers, it equals 107, and I divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 divided by 18. And it says that the Mean is 5 points. So here's I'm going to draw this, and the mean is 5.944. And you can tell that all our data is kind of just hovering around that 594, which means our math's not going to be that great. But on top here, and just, I guess I'll do it. What is this? 1, 2, 3, 4, 5. So that's 20. 15, right? 2 sixes is 12. 112 is 12. 1, 2, 3, 4, 5. 1, 2, 3, 4. 4 13s. 13 times 4 is 52. And then there's 2 14s, which is 28. So if I were to add that up, 20 plus 15 plus 12 plus 12 plus 52 plus 28. So that, if I add all of them, it's 139 divided by 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 divided by 17 is 8 points. So here is the mean here. The mean of class A is 8.17. Now I'll just draw a little line here. So you can tell that the math's definitely going to be bigger because look how far all the points there are much farther from the mean than in class B. Okay, so, and that's that. 9, what does this say? Let me just bring that down. Compare the mean absolute deviation for both groups. Write a couple of sentences comparing their variations to explain the results. In the high school competition, Michelle and Christina competed in the shot put event. Okay, the shot put. The distances in feet for the first 5 throws shown below. So you definitely have to find the mean. So let's find the mean on top. And that's going to be plus 48 plus 45 plus 57. Enter. So there's 250 divided by 5. And the mean is obviously 25. No, mean is 50, sorry. So the mean is 50 for Michelle, and then Christina is 48 plus 53 plus 51 plus 48 plus 50, and she's also 250. Oh. And then her mean is 50. So I guess, I think the better way would have been this. Let's see what I need here. So I'll do Michelle over here. And Michelle, the lowest is 44, so 45. So this is Michelle, 45. Michelle, 46, 47, 48, 49, 50, 51, 6, 7, 8, 9, 50, 51, 52, 53, 54, 55, 56, 57. So Michelle had a 48, a 50, a 45, a 50 again, and a 57. So that's Michelle. And then Christina, let's draw the same thing. The lowest she had was 48. So 48, 49, 50, 51, 52, 53, 51, 52, 53, and 148, 153, 151, another 48, and another 50. So let me change color. So let me put the mean here. The mean for both were 50. So I'm going to draw a line here that represents the mean. So look how close or how far these points are to the mean. And on this side here, look how close or how far these points are from the mean. So I should have done it to scale because you can definitely see that Christina's shot put results, the numbers are they're not spread out as much. Okay. So she would definitely have this one. The math would definitely be less than Michelle. You can always actually go and find the math to verify your results, right? To verify what I'm saying, which is that Christina is a more consistent shot put thrower, right? Okay. No, that's that. Uh-oh. No. Create a tree diagram. Okay, fine. So this will definitely be on your test. Creating a tree diagram. So I need a lot of them. So restaurant offers a lunch special for $9.99. You can pick one item from each category. How many different meals are possible? So here's my starting point. And my first choice, I'm going to write salad over here. So I can have a Caesar or a house salad. So, and then my second thing here is soup. So in the soup category, so I can have a Caesar with 3 types of soup. I like cabbage, I can get carrot, or I can get mushroom. And the house salad, same thing. Cabbage, carrot, mushroom. And then I have another category, the entree. So what do you want as your main meal? For the main meal, I can have Caesar salad with cabbage, soup, and then I can have 1, 2, 3 choices. So I can have the steak, the rabbit, or the bison. With each of these, I can have steak, rabbit, bison. The mushroom soup also, steak, rabbit, bison. And I'm just going to try to sneak this in. Steak, rabbit, bison. Steak, rabbit, bison. And then I'm going to make a smaller one here. Steak, rabbit, bison. And I added one more category. Yay. And it comes with a drink. So with each of these selections, I can have soda, coffee, and juice. Are we serious? Soda, coffee, and juice. Soda, coffee, juice. This one I can have soda, coffee, and juice. Soda, coffee, and juice. I'll just do the top. So again, soda, coffee, or juice. And with each one, yikes, soda, coffee. I promise you, your test question is going to be, you won't have 4 categories. So, I'm going to right now continue to talk. Soda, coffee, juice, and you get the idea, hopefully. So, if you were, and again, on the side here, I need you to write your sample space. So I can have, start with a Caesar salad. I can have a Caesar salad with cabbage soup. So I'm going to go, let's maybe highlight this. I can have this with a cabbage soup with the steak, and then with the soda. I can have the cabbage soup. Sorry, sorry. The Caesar salad, cabbage soup, steak, and the soda. Again, I can have the Caesar salad, the cabbage soup, with the steak, but this time I can have it with coffee. I'm here by then. Again, Caesar, cabbage soup, steak, instead of, and then my last drink is the juice. But that is just these 3, right? So you notice that, and then write your sample space. So I can have, so the total, your sample space is going to be, and if you use, there's 2 choices for the salad. There were 3 choices for soup. There were 3 choices for entrees, and there was 3 choices for drinks. All right, 2, 3, 3, 3. 2 times 3 is 6. Times 3 is 18, and 18 times 3 is 48. Yikes! What was I thinking? I apologize. So you're going to have a sample space that's going to have 48 different ones. So there are 48 different combinations that you could make out of these, out of this lunch special. And please, hopefully you watch the video before doing this, or actually you're watching the video as you're doing this, and you can stop right here. I'll move on. Let me just charge. Okay. Next question. Move on. 11. 85 out of the 340 students in the 7th grade earned platinum honor roll. If we could use the 7th grade data to predict how many of the 8th graders will earn platinum honor roll, how many of the 560 students in the 8th grade will earn platinum honor roll? Okay, so in the 7th grade, 85 out of 340. So that's the experiment, right? So we're using the experiment is looking at the 7th grade report cards and knowing that in the 7th grade, the experimental probability in the experiment here, 85. So the probability of platinum here in our experiment in the 7th grade was that 85 out of 340 earned platinum honor roll. So we're going to use this. Okay, if it says if we could use this to predict how many of the 8th graders would earn, how many obviously would earn it. So in the 8th graders, so we're going to take this data here, 85 over 340. We're going to multiply by, and then we're going to apply this to how many students in the 8th grade? 560. So let's see how much that is. Ugh. I'm going to take the 0 out, take that 0 out just to make it easier on the division. I can change the 34 to 17. I can change the 56 to 28, and that should be enough. So I'm going to multiply 85 times 28, and then I'm going to divide it by 17. So our prediction is that out of the 560 students in the 8th grade, 140 or 40 of them would earn platinum honor roll. Okay. 12. The table below shows the result of a recent survey. Explain how you could use a survey to predict the number of students out of 700 who would choose country as their favorite music. Alright, so let's see total number of students here first of all. Let's always find the total, right? So 9, 14, 15, 16, 20, 25. So there were 25 student survey. 25 students were surveyed. The total 25 students were surveyed. And we want to use this experiment to see how many out of 700 will like country music as well. So how many people like? 5 students out of the 25 polled like country music. So 5 out of 25. 5 out of 25. If you like to choose 1 over 5, that's fine too. And if you multiply that across, you're going to get eventually 700 divided by 5, and that's going to give us 140 students. So if we use this survey and apply it to here, we can predict that 140 students would like country music. Use the data below to answer this question. Who has the higher median? Ooh, wow. Okay, so remember the median is this, right? Q2. The higher median is the 2nd period class. So I'm going to just write the 2nd period class had the higher median. Who had the higher IQR? Well, let's do the IQR here. The IQR is Q3 minus Q1. Q3 is 90 for 1st period class and minus 75. So I'm going to label Q3, Q1. That's 25. Q3 minus Q1 for period 2 class. Well, this is about, we're going to have to like 92.5. I'm just going to write 91. And minus 80. Looks like 21, right? Approximate. So approximate. So therefore, first period class had the higher IQR. Which class had 50% of the students with a grade 80% or lower? So which of these 2 classes had 50% class? Well, remember, this is 25%, this is 25%, this is 25%, 25%. So look at 80, which is right here. Which class had 50% of the class under this score? Well, definitely the 1st period class, right? Because they had this 25 group and this 25% group. So 25 and 25, 50% of them had a lower test score than 80. That wasn't that bad. 14, which number represents the probability of an event that's very unlikely to happen? Well, so again, you can put them on a number line. If this is 0, this is impossible, and this is certain, right? It goes from 0 to 1. Just put the numbers. So 0.51 is about here. 1.2 is above the certain, so you can even take that out. 0.14 is somewhere around here. 0.9 is about here. So which one do we want? We want unlikely to happen, obviously. It's this one, right? The number very close to impossible. Which method is most likely to produce a random sample of the members of your class? Listing the first 6 students that come to mind? No. If I want a random sample of our class, would I just list the first students, 6 students? No. Choosing the 5 oldest students in the class? No. Writing the name of each student on a separate piece of paper and then drawing these slips from a hat? That's a probability. That's just like something you can do. Selecting the first 6 students to arrive at class? No. So this one would be the most random. Okay, C. 16. The pollster wants to find out if citizens are satisfied with a city council, which procedure would be most appropriate for obtaining a statistically unbiased sample. So something that's fair. Let's see if people are happy with city council. Interviewing people at a popular local shopping center. Surveying people whose names have been randomly chosen from the telephone book. Yikes. Placing an advertisement in the local newspaper asking for mail-in responses? No. So this is definitely no, right? Because those who are going to take the time to answer that obviously are biased, right? So that's definitely no. Mailing a questionnaire to people whose name has been randomly chosen, randomly from a list of customers of the municipal utility company. Also a no, because they might be biased because they're using the utility company from the municipal utility company. So therefore, they could say more favorable things if they're happy with the service. So that's a no. Which procedure would be the most appropriate? Serving people whose names have been randomly chosen from the telephone book. I was going to say B. Okay, interviewing people at a popular local shopping center. I'm going to also say no to this one because if they're happy with a shopping center, which obviously most of the times have to be approved by the city council in order to be built, right? So if they're at the shopping center, they're probably going to say, yes, we like the city council. We love the mall here. They did a great job. So those people will probably have a biased opinion. So B would probably be the most fair. 17. Compare the surfboard prices from shop A and shop B. What are 3 conclusions you can make from the double box and whisker? Well, the median from shop A, the median price for shop A is greater than the median shop price of shop B. The highest priced shop B sells the cheaper board. I know that because this represents the lowest board. Shop A sells, on the contrary, the more expensive board. The interquartile range, let's see, that's 400, 200. The IQR for shop A is greater than the IQR for shop B. What else can we say? I guess shop A has the higher end surfboards. 25% of them are 25% of their boards are more expensive than the highest priced board in shop B, right? This whole section here is more expensive than the highest what do you call? More expensive, the highest price surfboard in shop B. Shop B is definitely cheaper. Okay. Shop A has a bigger range in price, right? Not IQR, range in price, 900 to 300. So the range is 600. Here is 600 to 600 minus about 250. So it's about 350. So the range of prices in Shop A is definitely more. So you probably have a different, a greater selection of surfboards from cheaper to like super expensive. Okay, so those are all the things you can mention. And I think this is it. Yes, it is.